In this video, we are going to speak about matrices. So, what is a matrix? So, a simple way to introduce matrices is to think of a table. So, let's draw a table. So, have a table there. Now, let's put the number 1 here, 2 here, 3 here, 4 here, 5 here, 6 here. Now, everyone knows how to interpret a table where there is rows, there is rows, and there are columns. So, keeping that in mind, a matrix is a list of terms, be it numbers or variables or a combination of both, that consists of rows and columns. To be exact, this matrix has 2 rows and 3 columns. Now, the way to represent the number of rows and columns of a matrix is 2 by 3. This is not interpreted as 2 multiplied by 3, but when we're talking about matrices, it's understood. This is the number of rows, and this is the number of columns. So we say a matrix is a list of terms or variables listed analogously to a table, but we put 2 big brackets instead of the table. There is mathematical properties that is of interest in doing this that will be explored in this video and other videos to come. So when we speak of the number of rows and the number of columns of a matrix, this is called the dimension. So the dimension, hope I spell that correct, of a matrix is the number of rows and columns. It is usually denoted by n by m. So here would be n, here would be m. Number of rows by number of columns. Next example of a matrix would be A, B, C, D. So 2 rows, 2 columns. We would call this a 2 by 2 matrix. The first matrix was a 2 by 3 matrix. Now, some properties of matrices that are of interest to us is addition, subtraction, something called scalar multiplication, something called matrix multiplication, and something called the inverse of a matrix in order to solve simultaneous equations. Yes, simultaneous equations can be solved using matrices, but that will be discussed in a later video. Let's start with the simple operations. So addition. So let's make a so given matrix A as A, B, C, D, adding to matrix B given as E, F, G, H. To add matrices, we first make sure that the number of columns of the first matrix is equals to the number of rows of the second matrix. This property is called commutability of matrices. So the matrices are commutable. We need to make sure that any matrices we intend to do operations on are commutable. So now that we have discussed matrix commutability, the general form of matrix addition is as follows. So you add the corresponding elements from each of the matrix. So A plus E, B plus F, C plus G, D plus H. And similarly for subtraction, it would be as follows. So plus or minus, plus or minus. Let's see this with an example. So given the matrices 1, 2, 3, 4, plus 5, 6, 7, 8. Let's add. So 1 plus 5, 2 plus 6, 3 plus 7, and 4 plus 8, which would yield. Check for commutability. Yes, they are. Now, once we have established commutability, the numbers on the highlighted over there would give you the dimensions of the resultant matrix, which is the number of rows of the first matrix by the number of columns of the second matrix. That is the dimensions of the resultant matrix. So 2 by 2. So 1 plus 5 is 6. 2 plus 6 is 8. 3 and 7 is 10. 4 and 8 is 12. Now let's look at an example with subtraction. So taking the same matrices 1, 2, 3, 4, minus now matrix A, matrix B. Let's just call the matrix that results or the result of matrix C. So matrix A minus matrix B 1, 2, 3, 4, 5, 6, 7, 8 would be equals to 1 minus 5, 2 minus 6, 3 minus 7, and 4 minus 8, which results in the following. So 1 minus 5 is minus 4. 2 minus 6 is minus 3. 3 minus 7 is minus 4. 4 minus 8 is minus 4. 2 by 2. Check for commutability. 2 by 2 matrix. 2 rows, 2 columns. 2 rows, 2 columns. It is commutable. The resultant matrix would be a 2 by 2. So there we have looked at matrix addition and matrix subtraction. This here is the general form of matrix addition and matrix subtraction. It was given in terms of variables where A, B, C, D, E, F, and G, and H are any real numbers. Now, let's look at scalar multiplication of matrices. Scalar multiplication of matrices is defined as follows. So, keep this. So, K is the scalar. A, B, C, D is my matrix. So scalar multiplication is K by A, K by B, K by C, K by D. So let's take a scalar of 2 and multiply it by our matrix A, which is 1, 2, 3, 4. Scalar multiplication, you literally take the scalar and multiply it by every element. The things inside a matrix, or the terms inside a matrix, is called an element. These videos, I'm trying to keep the terms simple, the theory simple, so I would chuck in the proper terms now and then. So 2 by 1 is just 2, 2 by 2 is just 4, 2 by 3 is just 6, and 2 by 4 is just 8. So scalar multiplication is very simple. Literally take the scalar. The scalar could be any real number. It could be a fraction or real number. Fractions are a subset of the real numbers or part of the real numbers. So it could be anything and multiplied by each of the elements of the matrix. Now in the next video, we will look at matrix multiplication.